Hello my fellow researchers and welcome to another video in this video series called SPSS is Fun. My name is Jason and in this video I'm going to show you how to test the normality of your data. Now I've got three variables here and I've fixed the data in this variable to be normal and I fixed the data in this variable to be skewed. So we're going to be able to see what that looks like and how they're different. So let's go to our data view here. Okay, now again, we have age normal and age skewed. All right, and I fixed these data. For both cases, we have 36 participants, and you can see here our maximum value for age skewed is 40, and our maximum value for age normal is 30. But let's see how we're going to actually determine if each of these variables are normal or not. So we're going to go to our Analyze, Descriptive Statistics, Explore. Click on Explore. We're going to bring in age normal to our dependent list, and I'm going to put ID in our label cases by list. That's going to allow me to identify any outliers in the plots. I want you to click on Statistics and make sure you have outliers selected as well as descriptives selected, and then continue. For plots, I want you to make sure that you have histogram selected. I'm going to unclick stem and leaf. In this case, and make sure you have normality plots with tests selected as well. Hit continue, go to options. I'm going to have you choose exclude cases pairwise. In my data set it won't matter because I don't have any missing data, but if you have a missing data, generally you're going to want to use exclude cases pairwise, and I'll explain what that means in another video. Click on continue. Make sure you have both selected here under display. And we're ready to go. I'm going to hit OK. Again, this is our normal data, right? So everything here should look normal. Our mean is 25. Our median is 25. And our 5% trimmed mean is 25. So this all looks normal to me so far. If we look at our skewness value is 0. Okay, that's good. That's normal. If it was positively skewed, or if this value was positive, it would be positively skewed. If this value was negative, it would be negatively skewed. But it's 0, so that's normal. Looking at our kurtosis value, it's negative 0.545. That means that it's not normal, or it's not perfectly normal at least. If this value is negative, it means that the distribution is short and fat. Whereas if this value is positive, it means that the distribution is tall and skinny. So in this case, I'm looking at a short and fat distribution, or shorter and fatter than it should be if it was normal. Coming down to our tests of normality, here we have our KS statistic. I'm not even going to say his name, although he definitely deserves credit for this test. The significant value is 0.2, right? So any value that's less than 0.05 is significant, and any value that's greater than 0.05 is non-significant. So this test is non-significant, and that's good. That means that our data is normal. If it was significant, then we would be dealing with a non-normal data set. So this is good, okay? Let's look at it though visually. Visually, this looks pretty normal, right? It's not skewed left or right. However, we know from our kurtosis value that it's shorter and fatter than it should be, right? So this should probably come up a little bit higher here for it to be more normal. Looking at our normal QQ plot here, right, you can see the data points are deviating only slightly from the line. The line is our normal line, okay? And so if these data points were exactly on the line, then we'd have a perfectly normal distribution, but they're slightly off of it, so we don't have a perfectly normal distribution. Looking at this detrended normal QQ plot, it's basically almost a magnification of this plot. It's just plotting the deviation from these points to the line against this 0 line here. So what you want to look for really is just that nothing here is clustered, that you have nice spaces in between the data points, okay? And ideally you'd want them close to the line, but we have slight deviation from normality, which is okay. Now this is our box plot. Again, you know, this doesn't show anything abnormal. This looks pretty normal. Our median is in the middle, equal distances to our interquartile ranges. and equal distances to our maximum and minimum values. So this is normal, everything's good. Now let's check out our non-normal data. Again, here's our non-normal data set. Okay, analyze, descriptive, explore, same procedure. I'm going to remove that variable. I'm going to throw in the skewed variable. Everything is saved. All of our option settings are saved. So I'm going to hit OK. All right, now we're going to look at a non-normal data set or variable. So the mean is 26.22, which is different from our 5% term mean, which is 25.9, which is different from our median, which is 25. So we automatically know this is positively skewed because our mean is to the right of the median. Okay, and as well, the 5% term mean is less than the mean, meaning that we have some outliers here, particularly to the right, okay, in the positive direction, okay, because the mean comes closer to the median in this case. Now, what I'm going to do is check out our tests of normality. Okay, and in our tests of normality, again, we're looking at our KS statistic here, and this is significant. It's less than 0.05. So that means that we have a non-normal distribution, right? So automatically, we can't do any parametric testing. We got to do our non-parametric tests. Now, if you want to normalize your data, there's a bunch of complicated procedures you can go through. I won't be talking about those here. That would probably take hours. But for a simple test, right, this will suffice to check if you have normal or non-normal data. Looking at the histogram, right, you can see it's to the right. Okay, it's to the right. So what does that mean? Our kurtosis value must be positive, or our skewness value must be positive. Sorry, our kurtosis value depends on or determines the height, or is dependent upon the height. So let's check those values out. Skewness is 1.2. That's positive, so it's positively skewed. Kurtosis is 1.589. That's positive, so it's taller and skinnier than it should be if it was normal. It's taller and skinnier than it should be if it was normal. So if it was normal, it might be a little fatter and not as tall. Also, we know it's positively skewed, so these values are, this tail is too long. This tail shouldn't be so long if it was normal. Okay, again, continuing on with our normal QQ plot here, you can see a greater deviation from the line, right? So this is telling us something is off from normality. And now when you plot those values here, you can see that the distance between the points is less than they were for the previous plot we were looking at for the normal data set. So these are closer together, okay? And so we're looking at something that's non-normal. Here we look for our outliers, and here we can see this point way up here is past the maximum value, all right? And that's an outlier. And this 36, that's the ID number. That's not the value, that's the ID number. So it tells us, okay, so you got to look at case 36. There you have an outlier. Do what you will with it. There's lots of things you can do with outliers. That's up to you. I'm just showing you how to identify them. So these are our general tests of normality, or ways of looking at normality or describing normality. If you have any questions about that, feel free to send me a message. Otherwise, get ready for our next video in this video series. SPSS is fun. Thanks a lot for watching. Cheers.